Good day everyone, I am Teacher Jameson, your teacher for today's lesson. After watching this video, you will be able to represent points, lines, and planes using concrete and pictorial models. For today's lesson, I will discuss about representing points, lines, and planes using concrete and pictorial models. But before that, let me have an overview about geometry. Geometry comes from the two Greek words geo, which means earth, and metria, which means measurements. That is, geometry is about earth measurement. Now, the person who made a very significant contribution to the study of geometry was Euclid, known as the father of geometry. We associate geometry with shapes like triangle, rectangle, or any flat surfaces. Out of these shapes, we have points, lines, and planes, which are the building blocks of geometry and are considered undefined terms. Look at the things inside your house. Can you find objects that represent points, lines, and planes? Again, the three undefined terms in geometry are points, lines, and plane. Since they are undefined terms, we can only represent and describe them. Let us have point. A point has no dimension, it has no length, no width, and no thickness. We can think of it as an exact location in space. It is pictorially modeled by a small dot and is named by using a capital letter. These are concrete representation of a point. So we have a tip of a pen and mungo seeds. We may also include the corner of a table and a grapefruit. Next, let us have a line. So a line has only one dimension. It has infinite length, but no width and thickness. The two arrowheads tell us that it is extended endlessly in both directions. We can name a line by using 2 points on it, or by using a small letter. The pictorial model of a line is shown. So the following are concrete representation of a line. We have guitar string and the width of a window. We also have the edge of a book and the length of the leaves, representing the concept of a line. Next, we have a plane. A plane has two dimensions and it has length and width but no thickness. We can think of a plane as a flat surface that extends infinitely in all directions. We can name a plane by using at least 3 capital letters or by using a single capital letter. We can represent this pictorially by using a 4-sided figure. These are the concrete representation of a plane. We have a sheet of paper and a flat screen television. We can also include the screen of a laptop and the top of the table. Let us consider the relationship existing among points, lines, and planes. In the first figure, notice that the two lines L and M intersect at point O. Point O is a common point between two lines. Here, we can say that the intersection of two lines is a point. In the second figure, we have line AB intersecting plane M at point A. That is, there is only one point common to line AB and plane M. Observe that line AB does not lie on plane M. The intersection of a line and a plane where a line does not lie on the plane is also a point. When the line lies on the plane, the intersection is the line itself. The last figure shows plane L and N. The points that lie on line BC are their common points. Therefore, the intersection of plane L and plane N is the line BC. From here, the intersection of two planes is correct, is a line. Let's apply the concept learned about points, lines, and plane in dealing with the following examples. Tell whether each of the given concrete object is a representation of a point, line, and a plane. So let's have a solve. Correct, that is a point. How about the length of notebook? That's right, it is a line. Next, wall. Correct, that is a plane. How about the string of a flying kite? Correct, it is a line. Then, a magic wand. That is right, it is a line. Now, for example number 2, use the figure to answer the following questions. Letter A, name 5 points. Okay, so the points are A, B, R, S, and T. Letter B, name 2 lines. That is right. The 2 lines are line AB and line RT. Letter C, is line ST the same as line RS? Yes, line ST is the same as line RS since they are used to name the same line. Letter D, is line AB the same as line SB? Yes, line AB is the same as line SB since they are used to name the same line. Letter E, what point is common to line AB and line RT? Correct. The common point between line AB and line RT is point S. Very good. Now, always remember the undefined terms in geometry. So we have point, it has no dimension, it can be named by using a capital letter, and it can be represented as a small dot. Next, we have a line. It has one dimension, it has 2 arrowheads, and is extended in both directions. It can be named using 2 points or a small letter. Then, lastly, we have a plane. It has 2 dimensions. It is a flat surface that is extended in all directions. It can be named using at least 3 points on it or a capital letter. That's it. I think you are now ready to answer the exercises as well as the evaluation on your module. But if you think you missed something about points, lines, and planes, feel free to look back and watch again this video. Enjoy! See you next time!